I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh, yeah! Check out my new weapon. Piranodon! Oh, yes! Fires live piranhas. Ever seen one before? No, you haven't. I invented it. Do you want a demonstration? Oh, ah! It's so difficult sometimes to get the door on the back side.
Okay, so as you guys can see, what we're doing is not only famous in the math world, but also in Hollywood. What's up? So we're going to talk about vectors, and you may or may not have ever heard of a vector, but when you take physics or pre-cal later on in high school, you'll hear a lot about them. A lot of things like video game design, things like forces in nature, all of that can be demonstrated with vectors. And so just to steal from the movie, he really did define it how we do in math. A vector is something that has both magnitude and direction. So what is magnitude? Well, magnitude could be anything from the length of the vector. Just if you're looking at just a picture, it's how long it is. It could represent the speed of something. It could represent, it could also help represent force. So it just depends on the situation, but we really think of it usually as length in geometry because that's about all you guys are going to do with it. Is length. Now direction is pretty simple actually. Direction is just the angle. Okay, so this would be like, okay, I'm going to be heading 30 miles an hour due north. So when you're talking about direction, you really are thinking of a compass almost, north, south, east, west, and sort of what angle that you're at or what angle you're traveling. And now two vectors can come together and all kinds of fun stuff can happen. But before we get there, we just have to define a basic vector, which we have, but let's learn how to work with it, okay? Now I'm going to do this term here, basically using what you have shown on the screen, okay? So what we have is vector v, and the way that I have drawn this vector, there's an initial point and a terminal point. Now the initial point is where the vector begins, okay? So that is called your initial. Some people call that the tail as well. And then the terminal point, the word terminal means end, so that's where the vector ends. So we have initial point, and then down here we have the terminal point. So it's where the arrowhead's going to be if you want sort of a quick, easy way to remember it. So the arrowhead will be the terminal point. Now, if I wanted to talk magnitude and direction of this, I would actually grab a protractor and a ruler. And that's what I would do. I would measure how long it is, which this looks to be maybe 1.5 inches long. I don't know because I don't have a protractor. But if I wanted to measure it, I always measure from the initial. Okay, so if you want the direction, you need the initial point and you need a horizontal. So if you don't see a horizontal line, draw one in yourself, pick up your protractor, and this is what we would be looking for, is how far off is that angle. Now to me it looks to be about 40 degrees. So I would probably call that a vector that's 1.5 inches in the direction of 40 degrees. And you can say, you know, that it's going down. You can say that it's going south. I actually like to think of it as a compass. And so in my brain, I see this invisible north, south, east, west. So my brain would say, oh, okay, that's in the southeast quadrant. So I would call this 40 degrees south of east. And the reason it's south of east is because I start in the east and then I'm going 40 degrees south of that. So that's how I like to say it, but you'll see different types of things written. Okay, now when you actually see something like this, like sketch 2V, okay, I'm going to actually clear this all off just so we can go over that. Okay, if you want to sketch 2V, that number 2 is what we call a scalar. Okay, a scalar is sort of like a multiplier or a dilation, and I know you've done dilations before, so that should make sense. So all that it means is it needs to be the vector v but twice as long. Now the trick here is to make this twice as long, we would probably try to make it 3 inches long, but you can't turn the vector, guys. Like, it has to still be going in the same exact direction. So you have to get really creative and crafty with trying to keep, trying to keep them parallel, in other words. So I'm going to do my best. That looks like 1V. That looks like 2Vs. So if I pulled out a ruler, I could check it exactly, but I wanted to draw that twice as long, and I wanted to keep the angle the same. So notice how those are parallel. I didn't rotate it. I also still have the arrowhead going in the same way. Now, is there a way that the arrowhead might get flipped and the terminal becomes the initial and the initial becomes the terminal? Why, yes, there is, and it's with this example right here. So when I write negative v, the negative is saying I want it to be opposite. So an opposite vector means I'm going to now keep it the same length as it was before. So kind of like that. And I'm trying to draw it at the same angle. That was pretty terrible. Let's try that again. That's a little better. Okay. And I'm trying to keep the same slope as it was before, but it's negative. So it flips in a complete 180, which means that the arrowhead is now up here. So the terminal becomes the initial, and the initial point becomes the terminal. That's what a negative does. So what are we going to do with this? Well, before we can do application in the real world, we just have to practice combining vectors in space. And what this means is when you combine two vectors, you are typically adding them. And how are we going to add two vectors when we don't have numbers associated with them? There's two different methods. There's a triangle method, and there's a parallelogram method, okay? Now, on the triangle method, I actually use this one probably more. You combine the given vectors head to tail. Now, remember, head and tail are short words for terminal and initial. So you combine the vectors terminal and initial, and then you draw your resultant vector head to head. So this might mean nothing to you, but we'll do this example and hopefully that will make sense, okay? So what does this mean? All right, so what I'm going to do is I'm going to redraw V and W, but the trick is, in fact, I'm going to start with W. I usually like to start with the bigger vector. There we go. That's as best I can do. So there's my W, and I've brought it down. Notice I've kept it the same length. I've tried to make it look in the same direction, and now I'm going to put V together with it. I need to connect them, but I connect them head to tail. So in other words, I don't want to put V right here, because then their initial points would be stuck together. I need it head to tail. So I'm going to go to the arrowhead of this one, then draw V. That's connecting something head to tail. Now, a resultant is a solution. Resultant means solution. And the resultant vector is you combining them head to tail. So basically, it's like completing the shape. So it's going to look like a triangle. Shocking, right? I know you've never seen a triangle in this class before. So it's going to look like a triangle, but when you finish your answer, it's not just a line. This is a vector. It has a magnitude, it has a direction, but you have to show that direction by putting an arrowhead on it, and it's going to be at the top. You connect them head to head. So see those two arrowheads touching? That is the method, the triangle method. Now, some people like a parallelogram method. On a parallelogram method, it's kind of the opposite. You combine the given vectors by their tails. Then you draw the resultant vector as the diagonal of a parallelogram. Okay, so once again, we're going to have to draw what that means. So now I'm going to redraw V and W. So I'll do the same thing I did before. Here's W. And now V is a little bit shorter, but now this time I am going to connect them by their tails, okay? Because on this method, I'm not making a triangle out of it, I'm making a parallelogram out of it. So what does that mean? Well, it means that it needs to look like a four-sided figure where everything is parallel. So this line is going to be parallel to this. When I go across to make the fourth side of the shape, this line needs to be parallel to this. And from here, the resultant is going to be the diagonal of this. Boom. And on this one, the arrowhead goes in the corner. Now I want you to look at my two different methods, right? Two different methods, but look at the resultant. It is the same. If I got out a ruler, they would be the same length. If I got out a protractor and measured from here, they would be at the same angle. So it doesn't matter which method you use, you get to pick, and you could do either one of those, okay? Last one, if given a scalar or negative vector, make those changes before you combine them. Okay, so this is going to be, in fact, I'm going to change this to say 2v minus w. Okay, if that is 2v minus w, what you want to do is think of this as 2v plus a negative w. And what I'm going to do is draw those two first and then connect them. So first I want to work on what does 2v look like. So if I go back up to my v, okay, it's this little one right here. I want it to be twice as long, but in that, oh gosh, that was terrible. Twice as long, but in that direction. So that looks to be 2 v's, okay? A negative w means I'm going to draw the w one, but it's negative, so I flip the arrowhead to the other side. So it looks like this, but now the arrowhead's going that way. It might be just a little bit longer. Okay, so there is a negative w, and there is a 2v. Now to put those together, I'm going to use one of my methods from above. So I already told you guys I liked the triangle method better, so that's probably what I'm going to do. So I'm just going to pick up this negative w, and I'm going to stick the tail of it on the head of this guy. So here's my 2v. Here's my negative w. And I've put them together head to tail. The resultant is the third little side of that triangle, and then I connect it head to head. So the resultant is this green line with the arrowhead over here. So however long that is and whatever angle that's at, that would be my answer, my resultant. 2v minus w. That is what that's equal to. And that is your answer. Weird answer. It's a picture. Maybe highlight it so we know which one is your resultant, but that is literally it. So what it's saying is if these two vectors were forces, let's say, and this force acted upon this force, this would be how those forces ended up. So they'd end up at a different length or speed, and they'd end up at a different magnitude. So after we get good at this, we'll talk more about real world, when would you use this, but I promise it's used a lot. So let's just get good at the basics, and then we'll talk together about how or why. And now you get to practice. So have fun with that. Make sure you show your work. Oh, and use a protractor and maybe even a ruler to make it even more accurate. That would be awesome.